6.2 Solution of initial value problems. Today we will learn how to use Laplace transform to solve a differential equation. Let's start from the simplest one, a first order equation. Let's say -1 and then y0 equals 2. Everyone knows how to solve it because it's first order linear equation. It's really easy. And actually I can tell you the result. It's just that. Right, you can verify it because if you plug in this, take a derivative, into the t, so take the difference, you get -1, and then you plug in t equals 0, you get 2, so that's correct. Okay. Now let's see, how do we solve it using Laplace transform? Well, of course you can say, why do we bother, right? Because we already know the solution. But this is a test function, test problem. So we take the Laplace transform of both sides of your original equation. The right hand side is easy. If you remember, it's -1 over s, right? Because when you take the integral, this -1 can be put outside. And how about the left hand side? Well, L of y is unknown. So L of y, of course, is still unknown. Let me just call it capital Y. So the idea is not to write down what is the solution directly. It will create an equation for capital Y first. Then we recover the little y from that. So let's see, what is this? Well, we don't know what is y, so how can we integrate? Anyway, let's take a look. Okay, that's what we have. Well, although we don't know what is y, but since this happens to be a derivative, we can always do the integration by parts, right? Because that's something that works for any y. Okay, then you can see it's e to the negative st y minus y e to the negative st, and have another negative s coming from the derivative, right? So how about the first term? You plug in infinity, you get 0. You plug in 0, do you get 0? No, because this is 1. That's y0, and it's negative. Well, what does that mean? It happened to be a known number. See here? So negative y0 is a known number because it's initial condition. And the next term, you have this cancellation, so we have plus s times, this is integral. What is this integral? It's not known, but it's called capital Y. Okay, now let's put them together, see what we really have. You will have negative y of 0 plus sy, then minus y equals this side. So what we really get is not a solution, it's an equation. But this equation is for capital Y. And the nice thing about this equation is it's algebraic. There's no more derivative. You can just solve it by plugging the numbers and moving around as we did for usual algebraic equations. So what is the y0? y0 is 2, right? I think so. So this is 2. So we have moved over there. So you get s minus 1 y equals -1 over s plus 2. So what is y? Y equals 2 over s minus 1, and then you minus 1 over s minus 1. Right? And how do we... Okay, so in some sense we're done. We found our solution. But the next step is actually very important, and that's not so easy, is to recover this inverse transform. Recover through this inverse transform. So we want to find out y by this inverse transform. But we don't really have a formula for that. we will use something called a table lookup. In other words, we will construct this little y to make it work. How do we do that? Well, if you say what is the inverse transform of 1 over s, then you can recall from memory it's 1, right? So how about 1 over s minus 1? Well, if you remember, shift in s corresponds to exponential function in t. And this minus 1 gives you 1 over there, so it's e to the t, right? So, and this will give you 2 times that, okay? Now how about this term? Well, this itself is not in our table, but you can split it. Minus, so let's do a partial fraction. So the s and s minus 1. You can call them a and b. But if you observe, you can see if you choose them to be 1 and a negative 1, then the common denominator is that, and the numerator would be, you have s minus 1 here and negative s there, so it's negative 1, right? What we need is, well, you can just plus here become negative 1, right? So you can just combine this 1 over s with, see this negative 1 over s minus 1 and 2, so you get that. So you can write on your right hand side as that. Then you can use this and that to get a result. So y is 1 plus e to the t. And is that correct? Yes, I think that's what we get. Yes. So that's a typical procedure. You construct a function for capital Y and solve it, then recover the little y by inverse transform through table lookup. Okay, and in this inverse transform, you have to use partial fractions to make them into smaller terms. Okay, now let's apply to a high order equation. Second one, y double prime plus y equals 0, and y0 equals 2, y prime 0 equals 3. And the nice thing about this Laplace transform is that you can even apply to high order equations, say third order, even fourth order, so long as you can handle the fraction. So the right hand side is 0, so it's easy. The left hand side, we need to figure out what is this. Alright, so let's do it. Well, actually, this can be done through a formula. So let's recall what we had last time. We said y prime, remember what we had? We do the integration here, and we get that, right? So this means negative y0 plus s times capital Y. But what is capital Y? Capital Y is this. Alright, now to find out the second order derivative Laplace transform, we replace every y by y prime. Right? Because this is true for any function, so you can say y or y prime. And guess what? This is that. So we can do it again recursively. So you can see negative y0 plus s times this whole thing here, negative y0 plus s times, and this time I call it capital Y because it's just L of y. So this negative y0 minus s y of, sorry, this is y prime of 0, then y0, and plus s square y. Okay, and you can even make it high order if you want. So you can see this is negative y double prime of 0, negative s y prime of 0, and then minus s square y of 0, then plus s cubed y. Okay, so you can extend this list longer and longer. So the Laplace transform of a derivative of y will contains initial conditions of increasing order. Well, the derivative is decreasing order, but s is increasing order. And the last term is positive times s to the power of this, and then times y. Okay? And all of these numbers will be known, so it's completely determined. All right, now to apply to our equation. And minus plus y. So what do you get? You get negative y prime and negative y of 0 times s plus s squared y and plus y. And that equals 0, right? Let's see what is y prime and y. It's 3 and a 2. So it's negative 3 and 2. Right, 3 and 2. Alright, so what is y? You can move this one to the other side. So you have 2s plus 3 over s squared plus 1. And that's really neat, because just write on that. Then immediately you can recover y. What is this? It's a cosine. And that is sine. Alright, done. We got our solution. Alright, so let me state the advantage of Laplace transform. First, when you solve the equation for y, it's differential equation, right? But when you get the equation for y, it's algebraic equation. And algebraic equation is always easy to solve, right? Second, you don't need to determine C1 and C2 from initial condition. Initial condition is automatically included. So you get your solution directly without going through A1 and A2. And third, when we solve a linear equation with g term, we have to solve homogeneous and a non-homogeneous separately, right? First solve homogeneous, then solve a particular solution. And this will not be the case. We only need to solve non-homogeneous directly for Laplace transform, because you can just get to your right-hand side, in this case happen to be 0. But if it's not 0, then you get whatever you have on the right-hand side, then you get your solution directly. So you save quite a few steps, right? You automatically included your initial condition and right-hand side, and it's algebraic equation. Of course, there's the payoff. There's no payoff. There's the trade-off. The trade-off is that you have to convert the solution backward, and that's involves some partial fraction technique, and that could be a little bit challenging. Okay, and let's just do more examples. Say y double prime plus 2y prime plus y equals 4t for e to the negative t, and y0 equals 2, y prime 0 equals negative 1. Alright, let's solve this equation. Kind of just plug into the formula, right? So you remember this is negative y prime of 0, negative s y of 0 plus s squared capital Y, then I have double of, this is negative y of 0 plus sy, then plus y, that will give you 4, this is negative, so it's s plus 1, right? So let me plug in the numbers. This is 2, and this is negative 1, negative 1. So you have negative 2 plus s, and this is cancels, see plus 2, then have s squared plus 2s plus 1 capital Y equals 4 over s plus 1. Oh, this also cancels. Right, so just get y equals, this happens to be s plus 1 cube, square. Then you have 4 over s plus 1 minus s over s plus 1 squared. Alright, so let me see, yes. So you will have 4 over s plus 1 cube minus s over s plus 1 squared. Alright, what do we have for this one? Well, you have to, this is as simple as you can get, but this one is not yet, because the denominator is a power of first order function, so you should split this into that, or you can pull this out and become plus, like that. Right, then you can cancel one of them. So you have 3 terms. Okay, so you can write down them directly if you are familiar. This, if it's just 1 over s, then it's 1, but it's shifted, so it's e to negative t. Right? And this one, it's square. Do you remember what's square? It's, oh, sorry. Oh, yeah, my bad. So this is shift. But if you do the unshifted one, then it's this, right? And this is also a shift. Then you do the unshifted one, you get, sorry. You need to inverse transform of that, right? And what is this? Well, if you remember, we have that out of 1 over, t to the n equals n factorial t to the n, s to the n plus 1, right? So this means it's negative t, and that's 2t squared, right? Because this will give you 2 over s cubed. Okay, then you have e to negative t plus negative t, and this is 1 over s squared, which is just a t, right? T will give you 1 over s squared. So that's your result, e to negative t, 2t squared plus t minus 1. Okay, that's your answer. And that satisfies both equations and the initial conditions. Alright, I think that's it for the example. Okay. And we'll continue next time.